Standing on the shoulders of giants. This is the story of PostNL, how we embraced serverless technology, what it has brought us, the challenges we faced, and how we overcame them. I was really happy to attend Sasha's talk earlier this morning and Foy's talk after that, because they were about learning. And my talk will also be about organizational and individual learning. My name is Luc van Donkersgoed. I'm a AWS Serverless hero and principal engineer at PostNL. I work at PostNL. And PostNL is the Dutch National Postal Service. On average, we deliver 1.1 million parcels per day. We have over 38 now sorting centers, and we employ over 33,000 employees. So we have a very big logistics network, which is powered by advanced logistic processes and algorithms. And the application landscape powering these processes consists of over 70 applications, which are built by over 30 in-house engineering teams. PostNL is also a very old company. We've been around under various names since 1799. So this year we're celebrating 225 years of history. Now, you don't get to the ripe age of 225 without adapting to constant change. So over the centuries, we have changed from horses to cars, from physical post offices to the internet, and from letters to parcels. Now, in more recent history, software has really become an inextricable part of PostNL's operations. But the way we approach software has significantly changed since 2012. Because before 2012, we mostly used vendor-built and commercial off-the-shelf solutions, which were hosted in our own private data centers. In 2012, we decided that data centers should not have our core focus, and we migrated everything to AWS, making us one of the first public cloud-only enterprises in Europe. In 2018, we decided that to remain competitive, we had to build our own logistics software. So really to become a technology company. And we explored our options and we found that cloud-native services and serverless on AWS were the best fit for our business. And we optimized our engineering departments to optimize the use of those platforms. So why choose serverless as the foundation of our new engineering strategy? Well, there are a few reasons, and the first is elastic pricing, or pay-per-use. And pay-per-use is really important for a company like PostNL, because in an average week, the average workload on any of our applications might look like this. So as you can see, we hardly have any volume or any traffic during nights and in the weekends. But on Tuesdays, and especially around noon, we experience very high loads, because this is both when all of our delivery drivers are out, but also when our customers and consumers are using our apps and websites. But by embracing serverless, we hardly have to think about this increased load, because the cost, sorry, mixing up two topics here, mixing up the next topic. With patterns like this, we hardly generate any cost during the nights and weekends, which is a big cost savings when compared to always-on systems. The next reason to choose serverless is effortless scaling. And of course, scaling is important with patterns like this, with weekly patterns like this, but this is not the only seasonality that we see at PostNL. So here we see another usage pattern, this time covering about 6 months. You can still see the same weekly pattern because every one of these bumps is a single week, but you can also see another pattern, which is increasing load towards the end of the year. Now, can you take a guess what causes this pattern? Christmas season, of course. Because in November and December, we process about 2 or maybe even 3 times as much parcels as we do in the summer months. But by using serverless for these environments, we hardly need to think about this increased load, because the applications automatically scale to the adjusted volume. Now, of course, our AWS bill will be higher, but as we're also creating more revenue, this increased cost is automatically offset by this revenue. So we've covered effortless scaling and elastic pricing. And these are very important aspects of a serverless environment and good properties of a serverless environment to have. But to me, these aren't even the two most important reasons to choose serverless. So let me ask you another question. Can you tell me what the two most expensive components of software engineering are? People, that's one. And the other one is outages. So let's dive a bit into these topics. The most common cause of outages are infrastructure problems. So among other things, I'm talking about hard drives filling up, physical hardware failing, network congestion, or maybe misconfigured network. There are so many moving parts to infrastructure that building and maintaining infrastructure for large production workloads is an extremely valuable specialism. And as an enterprise, you must do it right, because outages are super expensive too. So, for example, if our logistics system is down, our sorting centers can't work, our delivery drivers can't drive out, and maybe our customers might demand compensation. And that also means that if you make your application builders responsible for their own core infrastructure, it will take them significant time and effort. And this is time and effort that they're not spending on creating customer value. Now, you could invest in separate platform teams or operations teams, but these are super expensive too. And remember, we moved away from data centers because we didn't want to focus on these kinds of topics. So instead, PostNL chose to mandate the use of serverless technology. And this allows us to delegate the most difficult infrastructure problems to AWS. For example, we don't think about physical CPUs or their compatibilities or their instruction set or their capabilities. We just use Lambda or Fargate or step functions, and Amazon automatically manages the physical capacity. Likewise, we're using a physical network, of course, between our applications and the services and the microservices. But we don't think about this network. We don't think about the bandwidth or the throughput or the volume or the speed of this network. Amazon just manages anything we can throw at it. And then there's high availability. And this is, of course, an extremely important, but also a very complex topic. It involves high availability zones, failovers, failure detection, immutable resources, and many more complex topics. But with serverless, we get all of this out of the box. We just write an object to S3 or a message to SQS, and Amazon takes care of the rest. And finally, another great benefit of using managed services is the security responsibility carried by Amazon. For example, when the Log4j vulnerability was found, Amazon patched their applications, their infrastructure, their virtual machines, their runtimes. They even patched the Lambda service to protect customer application code from abuse. And likewise, with the Heartbleed vulnerability, which was a vulnerability on the physical CPUs, they patched their infrastructure without any customer impact. And I think this diagram is such a great way to tell that story. All the way on the left, you have on-premises, and now as an enterprise, you're responsible for the entire stack. You maintain the data centers, you maintain the power supplies, the networks, the internet connections, the applications, the virtual machines, the entire thing. While all the way on the right, you are serverless. And now Amazon is responsible for almost the entire stack. They manage the data centers, they manage the physical security. They manage the redundancy and high availability. And if you use truly serverless applications, they manage the entire application for you. Like S3 or SQS or DynamoDB, you just get an API, you use the API, and they take care of everything under the hood. So what are the results? After 5 years of serverless, we've significantly reduced the number of outages and incidents at PostNL. We've created dozens of teams, which have released thousands of features over the years. We've also brought down overhead, both in a financial as well as in a productivity sense. And because we moved our teams in-house, they are now much better aligned with strategic and organizational goals. So we embraced cloud-native services, and we never looked back. It's all roses and unicorns in serverless land, right? Or is it? Of course not. Because nothing good comes without a cost. So let's talk about trade-offs. As any good software architect will tell you, and of course this remark is kind of dead, but everything is a trade-off. And embracing serverless is no different. So let's take a look at 4 commonly heard arguments used against serverless, downsides, if you will, and discuss their trade-offs in turn. First, serverless locks you in. And this is probably the most commonly heard argument against serverless. And honestly, I'm not even going to argue. It's true. If you embrace serverless, leaving AWS is going to hurt. But what is the alternative? You can try to avoid AWS services as much as possible, or you can invest in other platforms like Kubernetes. But have you seen the complexity required to run high-volume production enterprise workloads on Kubernetes? If you go that route, you take on the responsibility of building and maintaining and updating that entire platform yourself, which is exactly what we're trying not to do. With serverless, you're locked in, but at least you get to delegate the entire maintenance of the platform to AWS itself. The second argument is that serverless is expensive. People say that running production enterprise workloads on it will break the bank. And in this case, I might agree on the price per request, the price per event, the price per gigabyte stored. But again, this is a trade-off, because for this price, you get all the benefits we discussed before: security, scalability, reliability. And remember, when using a highly available and scalable platform, a mature platform like serverless, you're also reducing the number of incidents. And these are expensive, as we just discussed. So if you take all of these components into your total cost of ownership analysis, then you might find that the price per request or the price per event might be well worth it. The third argument is that serverless is complex. To run any application, you need at least 4 services. You need to know how they fill, how they scale, how they interact, what their limits are. But I would argue that this complexity is actually a good thing. Because if you run the same application in any other platform, private cloud or on EC2, or in your Kubernetes environment, you will likely have exactly the same components. They're just hidden somewhere in your internal architecture, maybe even in your application, which means that, again, you're responsible for building and maintaining it. Serverless brings complexity to the surface, where it can be discussed and replaced and documented and debated and analyzed, all while Amazon remains responsible for its operations. And then the last argument, serverless is too opinionated. And again, I'm not going to argue that serverless is opinionated. It is, and very highly so. But most of the time, this is with good reason. The limits and restrictions imposed by the service might protect an internal architecture, or it might force you to use the application the way it was intended. Or it might protect customer data in a multi-tenant system. The way we see it is, it's better to work within the limits of an opinionated system than try to work against them. So let's explore this topic of opinionated systems a little deeper. It is no secret that Amazon builds services for scale, right? For example, Amazon S3 processes 100 million requests per second on average. Lambda peaked at 126 million requests per second during Prime Day 2023. And Lambda processes 10 trillion invocations per month. So to run applications at these volumes, you need to adhere to very strict architectural guidelines and operational excellence. So AWS has decades of experience designing, building, and maintaining the largest services in the world. And the services in the serverless ecosystem are the embodiment of this experience. So by embracing serverless to its fullest extent, your applications automatically gain a base level of maturity that typically takes years to build. So in the end, PostNL's serverless strategy comes down to this. Our applications need to be reliable at all times, under any and also unpredictable loads. Distributed, decoupled, and elastically scaling serverless architectures help us achieve this goal. In other words, they help us reduce runtime pain. But in order to get these runtime benefits, we need to invest quite significantly at build time. So embracing serverless does have an impact. If we're going to use serverless to its fullest extent, we need to know its services inside and out. If serverless is complex, we need to train our engineers. If serverless has a high cost, a high price, we need to know how to optimize for cost. And if serverless is opinionated, we need to know the rules of the game so we can use them to our advantage. So what does this mean for a serverless engineer at PostNL? What challenges do they face? What skills do they need? Of course, they need to be very familiar with the serverless ecosystem. They need to know which services are available to them, what their limits are, their use cases, their failure modes, and maybe how multiple services like SQS and SNS, EventBridge, Kinesis compare to each other and when to use which. They also need to be able to design for scale. So for example, they need to think about throttling, about buffers, about queuing, about exponential backoffs, and all those kinds of topics. At the same time, they have to build with cost in mind. Because of course, any engineer can just choose to store every parcel update in DynamoDB. But would that really be the most cost-efficient option? Maybe another solution involving Kinesis Firehose or S3 can be used to solve the same problem more cost-efficiently. And finally, our engineers also need to operate our workloads. So they need to think about metrics, what metrics to alarm on, what the thresholds are, and how they are going to make their applications observable. In summary, our engineers need the knowledge to know what tools and services are available to them, and the experience to make the right decisions. And this is not easy. It requires long-term investment in people and culture. And one of the ways we do that at PostNL is by investing heavily in formal education, such as classes and workshops, together with AWS. We also foster our engineering community by hosting knowledge shares and by supporting community-led tech improvement charters, where the engineering community decides on our standards and our guidelines. We have found that continual learning and sharing our experiences is essential to support a cutting-edge software development company. At the same time, we've seen that a very effective way to promote good serverless engineering is by making the right thing easy. So for example, we offer one-click solutions to deploy new AWS accounts, which are then automatically integrated in our network architecture, version control, cost monitoring, and security tooling. But of course, we also need guardrails and guidelines. So, for example, we put service control policies in place which prohibit the creation of EC2 instances and IAM users. And this forces our developers to make the right decisions regarding cost, security, and operational overhead. So what have we learned? Embracing serverless is good for cost and reliability. But choosing serverless is not a flick of a switch. You don't decide to be a serverless enterprise and ta-da, you're it. Now you need to invest in your processes, your guardrails, and the AWS platform itself. You need to make the right thing easy and the wrong thing hard. And most of all, you need to invest in your people and culture and hire the experts who can build your serverless future. And in that sense, we strongly agree with Sasha's remark this morning. We define and organize the behavior we want to see, and the culture automatically follows from that. We have seen that the more we invest in serverless, the more we get to delegate to AWS. They become responsible for almost the entire stack, including its security, reliability, and high availability. And because serverless services are built to the highest standards imaginable and support millions and billions of requests per second, we have found that by embracing serverless, we truly get to stand on the shoulders of giants. Thank you.